Assalamualaikum warahmatullahi wabarakatuh. Okay, for today's video, I will explain about the ideal gas properties. Okay, as you can see, previously I explained about the how to find the properties of your substrate. But in this video, okay, if you have an ideal gas, so you can use this equation, which is the equation of state, to find the properties. Okay, so ideal gas properties, based on the equation of state, you have PV equal MRT, which is P is the pressure, P is pressure, V is the volume, okay, M is mass, R is ideal gas constant, and T is temperature. Okay, so P is usually in kilopascal, okay, V in meter cube, M in kilogram, R is kilojoule per kilogram Kelvin, and T in Kelvin. Okay, remember T in absolute temperature. So ideal gas constant, okay, can be found in A2, where here is some of the value for R, okay, for air, helium, argon, and nitrogen. Right. So when you can use the equation of state, when you cannot use the equation of state. So if the gas, okay, is if the gas meet the following requirement, then you can use the ideal gas equation. Okay, the first requirement, either or. The first requirement is P substain is less than P critical. Okay, let's say means that, okay, you have a P critical, okay, I think here, somewhere here, okay, so if the P substain is less than P critical, there, let's say PV diagram, okay, then you can use the ideal gas equation. Okay, T substain equal to 2 T critical and P substain less than 10 P critical. So this is the first, either 1 or 2. If you meet this requirement, then you can use the ideal gas equation, which is PV equal MRT. Okay. 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 And then, as you know that we also have water vapor. Is it possible to assume water vapor as an ideal gas? It is. The answer is yes, but only for water vapor with pressure less than 10 kPa. Why? Because if you use 100 kPa, there's some region that is not covered as an ideal gas. So we take only, okay, we can assume that the water vapor is an ideal gas only if it is less than 10 kPa, which is in this area, because this is vapor. Why not in this area? This is saturated liquid mixture, so this is in a vapor form. So anything that less than this, we can say that it is an ideal gas. However, in this class, you need to know that, okay, if you have water, even though it's a water vapor, please use the properties table instead of the ideal gas equation. Okay, remember that. Okay, ideal gas can be used if the question state that it is assumed as ideal gas, or in the textbook it use oxygen, air, hydrogen, nitrogen, and so on. Okay. Okay. So how you want to know that gas is ideal gas or not? Okay. So the ideal gas can be determined by compressibility factor. Okay, compressibility factor is denoted by Z. Okay, is the ratio of PV over RT. Okay, or V specific volume actual divided by specific volume ideal. Okay, if the Z is equal to 1, so it is ideal gas. If it's more than 1 or less than 1, it is real gas. So the nearest the value to 1, then we can assume it as an ideal gas. Okay. This is example, okay, of the ideal gas problems. Okay. So you have a tank contain argon. Okay, inside this is argon. We assume that argon is an ideal gas. In the beginning, state 1, okay, P1 is 600 degrees Celsius. T1 is 600 degrees Celsius. P1 equal to 100 kPa gauge. Remember, gauge. Okay, the argon is cool. So, there is a process which is cooling down. Okay, by heat transfer to the surroundings such that the argon reach a final equilibrium state of T2 equal 300 degree Celsius. Determine the final gauge pressure of the argon. Assume atmospheric pressure is 100 kPa. So, PATM is 100 kPa. Okay, that's a lot of hidden information in here. The first thing, a tank. Okay, if you can see a tank, usually, okay, it is a rigid one. Okay, so the volume is constant. Okay, volume is constant. And also, a tank is a closed system. So, the mass is constant. Okay, and you can say that the specific volume is also constant. Right? By using PV equal MRT, you can use at both states. Okay, let's say state 1, the PV is P1, V1 equal MRT1. Okay, at state 2, P2, V2 equal MRT2. Since this is constant, okay, you can get is P1 over T1 is equal P2 over T2. Okay, just put this equation inside this one. Okay, and then from this you can get what is P2. Okay, however, please be careful. P1 you need to change to absolute temperature, absolute pressure. And T1 and T2 also need to change to absolute temperature. Okay, you cannot use this equation using degree Celsius or using the gauge pressure. Okay, that's all. Thank you very much.